Hello, everyone. Welcome. Nice to see you all fresh and ready for your Saturday lesson. Hi, Swelise. Hello, Christian. Christian, we don't know very much about you. I think you're new to Watobe. How are you? Can you unmute and have a bit of a chat with me? Is he there?
Christian?
Hello.
Oh, there we go.
Hi, there we go in the chat. I'd love to hear your voice though, but I'm glad you are talking to me on the chat. And our usual suspects are here. Hello, Jaden. Oh, he doesn't have a mic at the moment. That's okay. I'm going to hold you to that though, because we have another lesson on Monday. So I'm going to check on that mic on Monday. Okay. How are we doing? Sakis, Weliche. It's so good to see you guys again. And Jaden and Michaela. So nice to see you guys. Okay, I hope we're ready for the lesson today.
Can I ask a really weird favor? Those of you who can you turn your cameras on for us so that you can say hello? It's just nice for me to be able to see a face to a name.
Like a wave, yeah, a wave.
Like a wave. You don't have to be on forever, just like a hello. Anyone who has their cameras that would be great. We got you. Okay. Okay. Before we sort of get going, because we've got quite a long workshop ahead of us, so there's lots for us to get through. I just kind of want to get an idea of where everyone is at with functions at the moment. So if you had to sort of honestly give yourself a scale from 0 to 10 with how you're feeling about functions and inverse functions, can you pop it in the chat for me, or you can unmute yourself and talk. 0 is I know nothing about functions. This is going to be my worst section in the exam, and 10 would be I'm feeling really confident. So just give me a number somewhere between 0 and 10 of where you're feeling with functions at the moment. You can just pop the number in the chat if you don't feel like talking. Okay, cool. Thanks, Michaela. Christian, thanks. Keep them coming in, guys. So, nice, okay. So, Liche, 4. Cool, thanks, Caitlin. Jaden, have I heard from you yet? Okay.
I'd say I'm a solid 9, ma'am.
Good cook. I'm so glad.
Yeah, I mean, I've probably taken many matric exam papers, but I think there might be a question I've never seen before. So instead of saying 10, like, I'm going to flex, I think I'll say 9. Yeah.
Okay. I'm going to say 9 3/4 because agreed. There's always like that chance of a question
just
popping
that
up.
One question, yes.
A tiny little one. Yeah. I do love functions. So functions are one of my favorite sections.
Yes, they are. Mine too.
Thank you, Jaden. Okay, cool. So I've got everyone's numbers. Cool. So what we're going to do is I thought that I'm a half. That the half is meaningful, so I'll take it. It does change us. It's it's a lot. What we're going to do before we jump into some past paper questions is actually just kind of write down some summaries of a few different functions, because sometimes if you're not feeling great with the actual base knowledge of the functions, then the questions just seem completely overwhelming. So if you've got some paper or book, whatever you're working on from studying, can you grab that? Make sure you have your calculators with you. Make sure you have rulers, pencils, pens, everything that we need for drawing graphs. Get your little station ready. And I'm going to jump straight into sort of talking us through some notes. I'm going to turn off my camera because I need to flip my screen, but I'm still here. So if you talk to me, I'm here. You don't need to feel stressed, and we can get going. Okay, so what you should be seeing here at the moment is basically functions is going to be in your paper 1 exam. Okay, it's normally questions 4, 5, sometimes it's question 6, depending on what the paper looks like. And it's around 32 marks, but there was a paper a couple of years ago where it was actually more than 50. So it's one of those things where it's a very important section to be able to do well, because it makes up a bulk of paper one. And if we can get these marks in our pockets, then it sort of helps us a lot as we move through the paper. And then with the more tricky sections, we've already got some things that we feel confident with. So let's just jump straight in. What type of graphs, some suggestions here, what type of graphs do we look at? Because we've got a whole bunch. Who can give me some of the names? I don't mind if you talk or if you put answers in the chat, either work for me. What are the different functions that we look at in matric? Beautiful, a parabola, thank you. Cool, exponential. A hyperbola, yeah, good. Okay, cool. So a quadratic also fits under here, under a parabola, and it's because a quadratic equation has an x squared and a parabola has an x squared. Beautiful. Inverse. Okay, and within inverse, we have a special new thing that we learn, which is what we learn for exponentials. Does anyone know what we need to do with the inverse of exponential graphs? What's something special that we have to learn with that? Starts with an L, if that helps. Yes, there we go, logs. Okay, so our log graphs. And then we've got our very, very, very basic beginner graph that we started with all the way back in grade 9, and that's our straight line. And the straight line graph, although we haven't done it since grade 9, you kind of touch on it a little bit in grade 10, you touch on it a little bit again in grade 11, but it's actually one of the most important graphs. It filters in to almost all the different questions. And they like to ask very sneaky questions with the straight line graph. They'll sort of talk about tangents, or they'll talk about equations that go through specific points, but they sneak in there. And if we forget about it, then we end up losing a whole bunch of marks. So let's kind of work our way through these and see. So we'll make a few notes on each one as we go. If you have questions, please ask. This is your time. This is for you. So this lesson becomes what you need it to be. If you ask me questions, I will sit on a question and answer them until you fully understand. So use this time. Use this time to ask whatever you're needing. And if you're feeling confused by something in particular, we'll sit on it until you feel a bit better. Okay. So let's start with our very basic graph, the straight line graph. What is the equation for a straight line graph? How would I write it? Y equals what? No answers coming in. I know you know this answer. How do we write a straight line graph? Y equals plus . There we go. Thanks, Ola. Plus C. Beautiful. Okay. The M is our gradient, and the gradient is the slope of a graph. Okay. So if our gradient is less than 0, then our graph is going to be sloping downwards, because remember, we always read a graph from left to right. So here, my graph is going down. And if our gradient is positive, then our slope will be going up. Okay. And if we're wanting to find the gradient, we would say y2 minus y1 over x2 minus x1, which is the change of y over the change of x. Okay, and this formula here is on our formula sheet, so it's not something we need to memorize, it's just something that we know. Thanks, Christian. I see your answer here as well. The C is telling us that it is our y-intercept, okay? And so our y-intercept is when x is equal to 0, and it's the point where our graph crosses the y-axis. So that value there, if that was a 1, then our C value would be 1. Okay, so that's kind of just very briefly talking about our straight line graph. Nothing fancy about it. Nice and easy. The most important things that we know are our gradients and we know C. Okay, cool. Let's move on to our quadratic or our parabola. Sorry if I'm coughing, guys. I had COVID ages ago and I can't seem to get rid of this silly cough. Okay. There's a lovely message there from Coco, everyone. Make sure you have a read. well, let's just call, it's not really a line. Let's just call it the parabola. I think that makes more sense. Okay. The parabola, what is our equation for a parabola? Who would like to tell me what our equation for a parabola is? Y equals what? You can tell me the most advanced one, or you can tell me the easiest one. Either way, I'm happy. Just something. Probably an cool. Okay, that's one way we can write parabola, absolutely, because it's a quadratic equation. So one of the options that we've got here is ax squared plus bx plus c. That's absolutely one of the ways we can write a parabola. Good. What would be another way we could write the parabola equation? Who's got a different answer here? So
In the turning point form, ma'am.
Sorry?
In the turning point form, where it's
Yes.
a bracket x plus p, close bracket squared plus q.
Yes. Nice. Okay, beautiful. So as was said there, that is our turning point way. And it's because our P and our Q value land up making up our turning point. Some of you would have learned that with X minus P, and some of you learned with X plus P. Both are fine. Okay. And then if we had learned it all the way from grade 10, because we hadn't learned about this horizontal shift yet, you would have just learned as AX squared plus Q. Okay. So let's chat about what some of these things mean over here. This A is telling us what our parabola is looking like. So basically, if A is positive, then we're looking at a happy parabola, okay, because it's like smiling. If A is negative, then we're looking at a sad parabola. So happy parabola, sad parabola. Q is telling us about our vertical shift. So how this graph is going to move up or down on our y-axis. So for example, let's say I had something like y is equal to 2x squared. So I've got no vertical shift. I know 2, that's my a value, is positive. So I'm going to have a happy parabola. I have no q value, so it hasn't shifted anywhere. So I'm looking like on 0, but it's a happy parabola. If I had something like y is equal to negative x squared plus 3, for example, just draw that quickly. That a value is negative, so I know it's going to be a sad parabola. My vertical shift is 3, so it's moved up by 3. And I would look something like that. Okay, now those ones are also quite nice and easy because I'm only moving my parabola up and down. When we start bringing P in, this dude over here, that is our horizontal shift. So that is how our parabola will move from left to right. For example, if I had something like this, and that was my turning point, and I said that that was negative 2 and 3, that's telling me my P value and my Q value. So if we don't know A right now, we could say that that was equal to y is equal to a, and then we're going to have x. It's always going to be the opposite direction to what it is. So here, my p value, it's moved left. Okay, so it's negative 2. So we're going to write plus 2 squared and then plus 3 because it's moved up. The funniest thing with P, or the most irritating thing with P, is it's always going to be opposite to the direction it's moved. So if we see that whenever we have, and this is for all of the graphs, whenever we have a P value, if it's like minus 3, then it's moved 3 to the right. If it's plus 4, then it's moved 4 to the left. Okay. Does anyone have any questions about straight lines or parabolas before we move on to some of our other ones? Anything you feel uncertain with? Okay. Cool. Okay. So let's move into a hyperbola. A hyperbola has got an interesting equation. Who can tell me the equation for hyperbola? Nice, Bendix. Okay, so A over x plus p, and again, you might have learned that as x minus p, which is okay, plus q. Okay, so Nice. Cool. So again, these things are kind of just telling us exactly the same thing. So once we know what P means and once we know what Q means, it's the same for all of our graphs, which makes it quite nice and easy. This Q is, again, it's telling us our vertical shift. And the P is also telling us, well, not vertical now it's telling us our horizontal shift. Okay. But these in a hyperbola, they also tell us something really important. What else does that P value and the Q value tell us in a hyperbola? What do we know about them?
Asymptotes.
Thank you. Yes, they are our asymptotes. Okay. And now an asymptote is when we have those dotted lines which tell us what's going on. Nice, guys. Okay, so let's say, for example, I had y is equal to 2 over x minus 3, and then let's say plus 1. Okay, our vertical shift, that plus 1, is telling us our vertical asymptote. So it's telling us this guy over here. Okay, because our graph has moved up by 1. So this would be y is equal to 1. Then we have this dude over here. Now remember what I said in our previous graph, it's always going to be in the opposite direction. So if it's x minus 3, we're going to go to positive 3 here. And we're going to draw our second asymptote. Okay. Now A tells us some important things. A tells us if A is positive, it's going to be in the first quadrant and the third quadrant, and if A is negative, it's going to be in the second quadrant and the fourth quadrant. So here we can see that A is positive, so we know we would have a graph in our first quadrant and we would have a graph in our second quadrant, and that means we would have both an X and a Y intercept that we would need to find the values for if we had to draw this graph. Okay. The other thing that comes up with hyperbolas, which it seems like a tricky question, but don't let it fool you, it's not too nasty, is they bring up this idea of the lines of symmetry. And lines of symmetry are literally just the lines that if I had a line going straight through, it's not super clear, straight through the points where my asymptotes meet, those would be my lines of symmetry. They always have the same gradients. So normally, when we have like just a basic hyperbola which hasn't moved in any direction, our lines of symmetry would look like this, and this would just be y is equal to 1x, and this would be y is equal to negative 1x. So they talk about this one as having a positive gradient, and this one as having the negative gradient. Okay. They could also talk about this as having a gradient of 45 degrees, because that's the same as saying it has a gradient of 1. Okay, so all of these things factor in. And then to get what this equation is going to be, we just need to see, well, how much has it moved to the left and how much has it moved up? And we can just figure out what our new equations are. But we'll get into that when we deal with one of the questions a little bit later. Okay, does anyone have any questions about hyperbolas? Are we happy? We're so quiet today. It's going to be a long 3 hours if you just have to listen to me talk. Okay, let's jump into our exponential.
Ma'am, can you
hello.
And I want to like quickly finish copying.
Yes, thank you. And thank you for talking. It's so nice hearing voices. Woo! Okay, how much would a question like this count? Okay, so if you had to draw a hyperbola, it would probably be worth, depending on if they've asked you to find things before. So sometimes they would have asked you to find these intercepts in a question before. So they would have scaffolded it for you a bit. It can be anywhere between 3 and 5 marks, depending on how scaffolded the question is. Unfortunately, these types of questions are quite rare. They don't give us lots of chances to just have a nice, basic, easy question where we're drawing things. The thing that's important for this is to actually know which formula to use and what the different letters mean, so that when we see more tricky questions, we know what to do. But we're going to go through a whole bunch of past paper questions just now, so don't panic. and then you'll see exactly what each one of them is worth. I've put it all packed together for you guys. Okay. You're welcome. Does anyone need to sit here any longer? There's no worries if you do. I know I write quite fast. My kids tell me all the time in class that I write too fast. Cool. Okay, so we're going to look at the exponential graph, and then we're going to quickly look at inverses, and then we're going to jump into some past paper questions. Okay, but I feel like you guys are answering really good questions so far, so I'm excited for us to get there. Okay, the exponential, it's one of those ones which it's sort of sold as a nasty graph, but it's actually not so bad. Can anyone tell me the formula for an exponential graph? There's multiple ways of writing it. Let's see if anyone can tell me how to write this guy. It's one of the graphs that everyone leaves out because they're like, no, I'm not getting involved in this graph. But it's actually not such a bad graph. Just got a bad reputation. Okay, yeah. That's super close. Okay, so what Benedict's written here is we've got a to the power of x. That's absolutely one of our sort of basic ways of writing an exponential graph. And when we're dealing with inverses, that's sort of the one that we look at the most. However, when we start dealing with metric exponentials, we have normally got an a value, a b value, then we're going to have x minus p, so that's our horizontal shift like we were talking about, and then we would have plus q, which would be our vertical shift, so that's moving up and down. Okay, so that's our horizontal and this is our vertical. Now, the same way that that q value was important in a hyperbola is this q is also telling us our asymptote in an exponential, but an exponential only has one asymptote. Okay, so whatever that q value is, that's where our asymptote is going to be. Then there's like a whole lot of different ways of saying when is it going to go up, when is it going to go down, and it causes a lot of unnecessary confusion. There are a couple things which are useful to know, but I will show you some tricks as we start going through some past paper questions that make these a little bit easier. The one thing that is helpful is A. If A is positive, then our graph is going to be above the asymptote. And that helps us with drawing. So sometimes it's nice to sort of just do a very quick sketch of what our graph is going to look like, and then we can see what our actual values would be. And if A is negative, it's going to be below the asymptote. And what I mean by that is if we have, let's just draw two graphs here. I'm going to put my asymptote here. We'll have the same asymptote. If it's above the asymptote, it could be increasing or it could be decreasing. And the relationship between that increasing and decreasing depends on the relationship of A and B. But that's not something you need to learn off by heart by any means. It's just useful to know that it would be above the asymptote if A is positive. And let's draw some more asymptotes. So it's going to be difficult to draw. Let's draw asymptotes here and here. When I say it's going to be below the asymptote, it could be increasing below the asymptote or it could be decreasing below the asymptote. Okay, so just for those of you who didn't sort of pick up what I was saying here, this would be an increasing one. This would be decreasing. And remember, we always read graphs from left to right, and that tells us whether it's increasing or decreasing. So if I'm going up from left to right, then it's increasing. Like here, if we look at this one at the bottom, I'm going from a lower point to a higher point, which means that it is increasing. And here I'm going from a higher point to a lower point, which means it is decreasing. So in a question, if they ask you, is this function increasing or decreasing, we just look at, is it going up or is it going down? Again, it sounds like a complicated question, but it's not so bad. Okay, again, P talks about our horizontal shift, but that's also not something we need to stress about right now. As long as you sort of understand this base concept, then exponential graphs aren't too bad. Okay, I'm just going to give you a minute to get that down if you're still needing to. We're going to jump into some inverse notes.
Ma'am, can I please ask a question?
Please, all the questions.
I'm not sure which past paper I saw this from, but is it possible to incorporate an exponential graph with a geometric series? Like a question?
Yeah. It's super, super nasty, but it has happened in the past. There was particularly a couple of years ago, there was a phase where they were trying to incorporate various sections across each other, but they can definitely bring geometric series in.
Okay, thank you, ma'am.
Yeah, I know that was not the answer you were hoping for, but
It wasn't.
they also love to bring in some questions of calculus into functions, because we need to remember that the first derivative is our gradient, and so that sort of comes into play sometimes as well. Oh, and I think we have a learner on our live stream as well. So hello, if you're there, welcome to our lovely lesson.
Yeah, I think it's one student, so yeah, we're very happy to have them with us. Yeah.
Yeah, yay, it's very exciting. Okay, let's move into our inverses. I'm going to kind of zoom through this. It's quite a big section that you spend quite a bit of time in matric, but it comes down to a few very sort of simple basic concepts that we can work with. The first very basic concept of inverses is we need to understand this concept of if it's a function or if it's not a function. Now, they love asking this question. Is this graph a function? Or what could you do to this graph to make it a function? So this is something that we need to focus on. And basically, if I have a graph, like let's just do a straight line, or if I have a parabola, or if I have a hyperbola, or if I have an exponential, okay? If you take your ruler and I know this sounds bizarre. If you take your ruler and you place your ruler anywhere, so imagine that this pink line I'm drawing is the ruler, and I put my ruler anywhere on this graph, it would only sort of cross my graph in one place. So I'm going to put my ruler there, it only crosses my graph once. If I put my ruler there, it only crosses my graph once. If I put my ruler there, it crosses once. There, once. If I put it there, once, there, once, there, once. And so if we move our ruler across the graph and it only touches the graph in one place, then it is a function, okay? Because it only has got one y value for every x value. However, we do start looking at things that are now not a function. So for example, the inverse of a parabola looks something like this. Okay, that's one of the options for an inverse of a parabola. It could look a whole bunch of different ways. And now, if I was to take the ruler and do that same test that I've just done on those ones, and I put my ruler over here, now all of a sudden I have got two y values for one x value. And if that is the case, if my ruler hits the graph in two different places at one x value, it is not a function. Okay, so an inverse of a parabola is definitely not a function. And they can say to you, is this a function? And you would need to say, no, it's not a function because it has two y values for every x value. Okay, another example of not a function, which is why we don't learn about them in functions, we learn about them in analytical geometry, is our circle. And again, if I put my ruler anywhere on that graph, I'm going to get 2 points. So it's one of these situations where we have to just kind of be aware of what we are looking at and how we can best answer the questions that they're needing. So in this case, we've got a point here and a point here. So this is not a function anymore. Okay. Now, this is where it gets a bit nasty. They will say to you, how can you restrict this graph? So how could I restrict this inverse of a parabola to make it a function? And now we know that if it's crossing in two places, it's not a function. And so a restriction is saying, basically, if I just had this top arm and I didn't have the bottom arm at all, then I would only be getting one y value for one x value. So if I only had this purple arm, then it would be a function. Or if I only had this green arm and I didn't have the purple arm, then it would be a function. And so we do restrictions so that we only get one arm of the inverse of the parabola. Again, we'll talk about that a bit more later on, but this is just to sort of remember what is a function and what is not a function, so that when we get asked, is this a function or is it not a function, we know how to answer. Okay, the one you need to look out for is always your inverse of a parabola, because that is not a function, and then we need to explain why. Okay, the other fundamental thing about inverses that we need to know is basically we switch around our x and our y values. They just change around. And we can do an inverse of any graph. So if I had like a straight line graph and I had y is equal to 2x plus 6, for example, if I wanted the inverse of that graph, I would first need to switch around my x and my y. So I'd say x is equal to 2y plus 6. And then we need to get y to be the subject of the formula, because that's how we always write our graphs. So I'm going to say 2y is equal to x minus 6, which means y is equal to a half x minus 3. That would be my inverse function of the straight line. And we can do it for any graph, for hyperbolas, for parabolas. Parabolas will need a restriction sometimes. But when we can't do it is for our exponentials, and that's when log comes into play. So for exponentials and their inverse, if I have very basic thing like y is equal to 2x, and I wanted the inverse of that graph, the first thing I have to do is I have to change my x and my y. And now I need to get y to be my subject of my formula. And the only way for me to do that is to use log. Okay. So for anyone who doesn't enjoy log or doesn't remember log well, this is how I remember how to use my logs. Maybe it will help one of you. I use something that I know. So I know, for example, that 2 to the power of 3 is equal to 8. That's something that I know. That's not something I need to think about. I also know that when I'm using my log function, if I have 2 and an 8 over there, what this is actually saying is, what does 2 have to be to the power of to give me 8? That's what this question is saying. And the answer to that is 3. So 2 would have to be to the power of 3 to get to 8. And so whenever I'm dealing with log questions, I just write this down, because that's something that's easy for me to remember and easy for me to just think logically that makes sense. And then you can just put it into place. So we're looking at this situation up here at the moment, and we need to get it into that situation over there. So we would say, well, we're going to have y, let's put that there, is equal to log, and then we're going to have our base 2 x. And that would be our inverse equation of an exponential graph, which becomes our log graph. Sure. I can hold on here as long as you like. Does anyone have any questions about this, or is anyone feeling like horribly confused? I am obviously jumping through everything very quickly. This would normally take weeks and weeks to do in class. Just trying to give you basics of everything before we jump into the questions. Sure. Is that enough? Hopefully that's enough. Try to get that whole page in. For inverses, do they only test exponential? Because I've seen exponentials in past. So for inverses, they actually, it's very rare for them to test sort of straight line inverses because it doesn't really do much. They love testing inverses of parabolas because they can be quite nasty questions. I think in one of the questions we're going to look at today, which was in the 2018 paper, that whole question was the inverse of parabolas. So really the two main ones that come into inverses are parabolas and exponentials. But we are going to dive into those questions today. Sure. The other useful thing for inverses is to just always keep this in mind, that those x values and y values just change. So for example, if I have a graph and I knew my coordinates were 3 and 6, then in my inverse, the coordinates will be 6 and 3. And if we just always keep that in mind, it makes plotting an inverse quite nice and easy because we just switch those coordinates around.
So let me just switch the coordinates around and not the sign.
Yeah, exactly. So like let's do an example over here. Let me just draw us a little graph. Because the whole point of an inverse is it's actually a reflection over the y equals x line. This line here is y equals x, and inverse functions are a reflection over that line. So if I had let's say I had a parabola that looked like this. Let's make it a bit wider so that it's easier to see the reflection. Okay, and I was given point over there and told that that's -3 and 9, and that this point here was 3 and 9. If I wanted to draw the inverse of that graph, I can literally just switch those coordinates around. So I could say, well, it would be 9 and -3. Okay, so 9 and -3, somewhere around there, and then it would be 9 and 3, which would be somewhere over there. And so if I drew my new parabola, it would just be, obviously this is horrifically messy, but you understand what I'm trying to say. It would look something like that. So this would now be 9 and 3, which was the inverse of this one, and this one would be 9 and -3, which is the inverse of that one. So we can literally just switch the coordinates around. But now in this situation, so if we looked at this parabola, this might be a nice thing for us to look at, is if they asked you now, is the inverse of this function a function, we would have to say, no, it's not a function. And so then it can say, can you restrict this function to this inverse to make it a function? So they'll ask you to restrict the domain of our original function. So remember that when we're talking about a domain, oh, sorry, I think for the live stream, that color doesn't work really well. Let me work with a bit of a darker one. When we're talking about domain, we're talking about x values. And when we're talking about range, we're talking about y values. Okay. And now, obviously, for an inverse, those would switch with each other. So our domain for a function would be the range for our inverse. And so if they're asking us to restrict the domain of this light blue graph so that we would only have one arm, for example, if I said, that yellow is not going to be great either. If I said that x has to be less than 0, so I'm restricting my domain, I'm actually only looking at that arm there, which means if I'm plotting the inverse of that arm, I would only be looking at this arm here. And that, just drawing that one single orange arm, is now a function, because if I drew my ruler, I only have one spot where my ruler is going to hit. And so this is sort of how they like to ask parabola questions. So we have to restrict the domain in our original function so that our inverse is still a function. Does anyone have any questions about any of this? We're going to jump into past paper questions after this. So if you need sort of clarity on anything, now's your time to ask. Okay. Okay. Oh, yeah, sorry. When you restrict the domain with the inverse, yeah. So the thing is, if I restrict the domain, because inverses switch with each other, a restricted domain in our original graph becomes a restricted range in our inverse. And so our inverse restriction becomes y has to be less than 0. But we don't have to explicitly say that because we will see that it has changed from there. Yes, I definitely will do another example of domain restriction in one of the questions that we come through. It will come up. Sure. Okay. Okay, so let's have a look at our first question. So this one is from November 2019. I'm going to try and see as much of space as I can over here. Okay. I'm going to talk you through a few things that sort of help you set stuff out as we read a question, and then I'm going to let you try a few of them by yourself. So below are the graphs of f of x and g of x. And so sometimes it's just helpful to just figure out what's going on. So we can see that this graph here, that's our parabola, okay, because that's f. And then g of x is going to be our hyperbola. Cool. If you have highlighters, this is a great time to highlight as well, so that you know exactly what's going on. So you know what f is and you know what g is. F has a turning point at C and passes through the x-axis at 1 and 0. So we know that that point is 1. D is the y-intercept of both f and g. Okay, so we know that that is a y-intercept over there. The graphs f and g also intersect each other at E, so at this point over here, and at J. The vertical asymptote of G passes through the x-intercept of F. So it's just saying that this asymptote is passing through the same x-intercept, which is that 1 value over there. Now, reading this information is always really important. Don't ever just skip over that. Okay. So all I want you to look at the moment is try for the moment to do 4.1 and 4.2. And we're going to talk about a few traps that they're trying to set for you in these two questions. But let's see. So first, just work through those first two questions. And if you need help, let me know. I'm here. So to find A, we could do multiple things. We do have the point 1 and 0 is definitely a good place for us to start, though. Yeah. Well, as long as you've already, yeah, but you would have already found P, so yeah, that's fine. There should be a key happening up here in this equation that should be like ringing alarm bells. Because right now I can see sort of what I'm envisioning is a few panic modes that at the moment the only coordinates we have are 1 and 0. But we actually have more than that. We just have to read the question. I don't want to give away too much just yet. So who can help out here? Who's figured out the coordinates for D? Has anyone seen it yet? Well, very close, just the other way around. Okay, so D, the reason that this question was tricky, but not really tricky, beautiful, is because in our parabola, they've told us over here that our y-intercept is -3. And so that's our y-intercept over there, which means the coordinates of D are going to be 0 and -3. So our x value is 0 and our y value is -3. Okay, that's why this equation up at the top was so important. So that's, I'm going to let you try a little bit longer, but that was really necessary in order for us to work out the rest of these questions. Okay, let's chat about a couple of things here. So finding the value of P, that shouldn't have been too tricky. So P is our asymptote, okay? And we can see that it's running through this point 1 and 0. And so our first point over here is that P, remember, it's always going to be opposite to the direction. So we've gone 1 in the positive direction. So P is going to be -1. Okay, so that's our first point. P is -1. If you got that, give yourselves a mark. Brilliant. The second question is sneaky. This is where they like to set traps. So first of all, they've told us show that A is 3 and B is 2 because they're worried not everyone is going to be able to find A and B. And if you can't find A and B, then you wouldn't be able to do the rest of the questions. Okay, so they've tried to help you by giving you the values for A and B, but we're not allowed to use them. Whenever you have a question that says show that or prove, we basically have to pretend like we don't know this information. It has never existed. It's not in our heads. We're not allowed to use it. Okay, it's basically just there to check that our answer is right at the end, or to help us if we can't figure it out, then we can use those values for the later questions, but we're not allowed to use them when we figure out these values. Okay, so the key in this question, and the reason that they said show that, was because they were pretty sure not many people were going to see that D was 0 and -3. So firstly, let's try and find A. So that's dealing with this equation over here. We know that Y is equal to A over X minus 1, because we've already found that P is -1. D is in both of our graphs, so we can substitute those values in. So Y is equal to -3 and X is equal to 0. So 0 minus 1 is -1. I'm going to move that -1 up. And so A is equal to 3. Easy. Okay. For f of x, to find B, at the moment, we have got y is equal to x squared plus bx minus 3. Again, I'm going to substitute in this value of 0 and -3. So -3, oh, sorry, no, I'm not. I'm going to substitute in the values of 1 and 0. Timothy, I'll come to that question just now. I'm just going to finish off this one, and then I promise I will be right there. So y is 0, x is 1. So we're going to have b minus 3, which means 0 is equal to b minus 2, and so b is 2. And so we have found what a is, and we have found what b is. Okay, let's get to these questions. Timothy, would they ever ask us to find A, B, and C? And if so, what values would generally be given? Okay, they can ask you to find A, B, and C, but they would have to give you 2 points on your parabola. and you would most likely have to do a simultaneous equation. And most of the time, if they wanted you to find A, B, and C, they would give you 2 x-intercepts. But it depends on how they want you to find the question. Why is it x minus 1? Okay, why is it x minus 1? Because when we're dealing with our asymptotes of the hyperbola, it's always going to be in the opposite direction to what it is. So because this is this positive 1 happening over here, we're going to write minus. It's always going to be opposite to what it is. And the reason we do that is because if we're trying to figure out where it would be 0, we would say x minus 1 is equal to 0, and that's when x is equal to 1. And that is when x is equal to 1. So it's always going to be the opposite sign to where it is. It's the same as if I had, let's say I had one chilling over here that was x is equal to -4, then I would write that as x plus 4 at the bottom. It's always going to just be the opposite to what it is. Okay. Okay. Any other questions with 4.1 and 4.2? Okay. Let's give 4.3 a try. I'm going to write our equations for our graphs over here so that I can scroll up a little bit. So we've got f of x, which is equal to x squared plus 2x minus 3, and g of x, which is equal to 3 over x minus 1. Okay. All right, so 4.3, calculate the coordinates of C. That's over there. And 4.4, write down the range of F. If anyone is having success with 4.3, I'd love to see what your answers for C are. You can chuck them in the comments, or you can let me know. You can chat to me. I'd love to know what your answers for C are and what your answers for the range would be. But let's first find the coordinates of C. Beautiful. Yes. Nice. Okay, I'm going to give you a couple more minutes to finish this off. Okay. So our coordinates of C. C is our turning point. Now, there are lots of different ways of finding our turning point. The easiest way is our x value of our turning point is minus b over 2a. Now, remember in your original equation, your a here is 1, your b is 2, and your c is -3. Nice job. Well done, guys. Awesome. Okay, so minus b over 2a, your x value Obviously, please don't work sideways like I'm working. Make sure your working out is nice and neat and organized. So we'd have minus 2 over 2 times 1, which is 2, which gives us -1. So our x value is -1. And then we're going to input that. So this is the important formula, and this is one that's not given to you on your formula sheet. So if it's something that feels foreign to you right now, that's the way we find the x value of our turning point. You could actually also do it through calculus with and finding maximum points with your derivative, but let's not talk about that right now. Your y value, you're then going to sub in that x value into your f of x formula. So we're going to have 1 times -1 squared plus 2 times -1 minus 3. And if we chuck that whole thing into our calculator, we get our answer of -4. And so our coordinates for C are -1 and 4. So note to yourself, if you're looking for the turning point of a parabola, you first use minus b over 2a to get the x value, and then you sub in to the formula. That would be our second step. Okay. Write down the range of f. Okay. Now I need to talk to you about something serious here. Let's say hypothetically, in your exam, you couldn't figure out 4.3. Okay, you tried something, but you couldn't get an answer. It's important that you write down something so that you could answer 4.4. So your range is we're looking at this graph here. Okay, so we're looking at this green graph that I'm drawing in. The range is all of our possible y values. So the smallest that our graph can be is -4, which we've already worked out. So I know from my graph that y has to be greater or equal to -4. However, if I couldn't find my turning point in 4.3, I then can't answer 4.4, which means I lose another 2 marks. So what I recommend you do, if you're really struggling and you can't figure it out, put in a number that makes some kind of sense. We know our y value needs to be less than -3, and we can see that our x value would be negative. So let's say you got it really wrong, but you said -2 and -5. Let's say you wrote that as your turning point. Whatever you write there, you can then get continued accuracy marks for your range. So we could say here, y would have to be greater or equal to -5. And you can get marks for that, even though it's wrong, because it's dependent on what answer you got in the previous question. The range is definitely looking at the y value. It's just saying what are all the possible y values that f could be. And I can see that the smallest that f could be, the smallest y value that f could be is -4. So my range is saying that y can be anything that is bigger or equal to -4. That's what our range is telling us. It's just saying what are our possible y values. So what I'm saying here on the right is just, if you couldn't answer 4.3, try and put in some kind of answer that makes sense so that you're still able to answer 4.4, because you don't want to leave blank spaces in your matric exam. Your markers will always try and help you and try and find marks for you, but they can't do that if you leave blank spaces. Benedict, did I answer your question about the range, or have I not really? Okay. Last one on this question, and then we're gonna jump up and stretch a little bit. Determine the equation of the line that goes through C that makes an angle of 45 degrees with the positive x-axis. Write your answer in the form y equals. Again, it looks like a horrible question, but it's not a horrible question. I'm going to get rid of all of these bright colors I have going on here so that I can explain a few things. All it's saying is I have a line that is going through C. And that's not really a straight line, is it? It goes through C, okay, and it's making a 45-degree angle with the positive x-axis. That's all that's saying. And I want to know what the equation of that line is. Y is equal to mx plus c. I want to know what m is, and I want to know what c is. And this is another reason why putting in some value in 4.3, if you couldn't figure out 4.3, is important, because we would need it for 4.5. Let me know if you are happy with some answers coming in. My first question to you is, if it's creating an angle of 45 degrees, what is my gradient? What would my gradient be? So what's m? Beautiful. M is 1. Okay, well done. And remember, if you ever forget that, remember that tan theta is equal to your gradient. And if we work out tan 45, we will get 1. Okay. That's from analytical geometry, which will help with one of your later questions anyway. So we already know that y is equal to 1x plus c, and we know it goes through point C. So that should help you. This is a baby C, not a big C. And we know that the coordinates of C, because we've already worked it out, is -1 and -4. So what is my equation going to end up being? Beautiful, Benedict. That's beautiful. Okay, so I'm going to sub in my coordinates of C into this equation. So I'm going to sub in -1 and -4. The -4 is equal to 1 times -1 plus C, which means -4 is equal to -1 plus C. And so C is equal to -3, which means Y is equal to 1x minus 3. And that is our first question done, and our first hour. Okay, so I just want, I think Coco will agree, we just need to have a bit of a stretch. So if everyone can just get up and stretch your arms, take a big breath in, jump around, maybe do a few jumping jacks, maybe do a few squats, wake up the brain, go get some water, stretch your body out before we move on to the next question. Do a nice little stretch, do a little dance. Is everyone stretching? I feel like I'm the only one stretching. Oh, Benedict, I took this from, this was from, I put it up here, November 2019. Have we all stretched? Can we move on? Have you been to the bathroom? That would be a very, very, very quick bathroom visit. Okay. Cool. Cool. So this was November 2019. That was question 4. And this was question 5 of November 2019. So let's have a look at what's going on over here. So sketch below is the graph f of x is equal to k to the power of x, and it's telling us that k is positive. The point 4 and 16 lies on f, and the first thing it wants you to do is find the values of k. Now this should be a nice easy question. They've given you values. They haven't tried to trick you with anything. Can everyone please find the values of K for me and tell me what they are? You can check them in the comments for me, or you can let me know. And once you are happy with your values of K, you can jump straight on to 5.2. Yes, the recording of this lesson will definitely be available to you. You can just go onto the Watobe app, and then you can go onto Matric, and it'll take you to here. You can watch it whenever you're needing to.
Oh, ma'am, the website, the website.
Sorry, yes, not the app.
watobe.co.za.
Sorry,
Yes.
you're absolutely right. I'm just spreading lies over here.
No, and they'll also be on YouTube in our exam prep playlist. So you'll be able to find everything that we've done for this right before your exams. They'll all be there, so you guys can go look at them again. Okay.
But remember, like, we can, this whole lesson can be, it's based on what you're wanting and what you're needing. So if there are things that you're not understanding, you just need to ask, and we can go through those specific questions, and we can spend time on it. And you must ask as much as you need. This is your time. You must use every second that you can. I will never, ever, ever get irritated with questions, I promise you. I love questions. Has anyone managed to find our value for K just yet? Nice. Cool. Okay, and they told us that K was positive. Nice, guys. So there are lots of different ways you could have done this. I think how I would have done it, I think what I would have found easiest is said that 16 is equal to K to the power of 4. And so 2 to the power of 4, well, let's say, and also, well, is equal to K to the power of 4, but also negative 2 to the power of 4 is equal to K to the power of 4. And so therefore, K would be equal to plus or minus 2, but they told us that K had to be positive 0, therefore K is equal to 2. Because they've told us that K has to be bigger than 0, you could have just skipped that whole side that said negative 2, because they've already classified that it has to be greater than 2. Yay, we have our values of K. That's awesome. So now we know that our graph is y is equal to 2 to the power of x. Okay. Graph G is obtained by reflecting graph F about the line y equals x. Now, when we see this, as soon as we see this sentence, reflecting the line about y equals x, that's telling us it is an inverse, because the whole point of inverses is to reflect over y equals x. So they like to ask it in this way because it confuses people. Determine the equation of G in the form. So basically, all they're asking, they've written all these words, they just want the inverse equation of this. That's it. That's all they're wanting. All these nasty words for a nice, easy answer. And whenever you're feeling confident, tell me what that answer is. Nice. Beautiful. Okay, so whenever we have an inverse, the first thing we're going to do is we're going to flip around our x and our y. So we're going to say x is equal to 2 to the power of y. Now we need to get y being the subject of the formula, which means we need log. And so y is equal to log 2x. Beautiful. So at this point, we should be sitting on 4 marks, which is lovely. 5.3, sketch graph G. So that's what we've just figured out. And indicate on your graph the coordinates of 2 points on G. I'm going to give you a couple of minutes to try and sketch this out. Remember, it's 4 marks. And then I'm going to talk you through a few things that will make it a bit easier if you hadn't done those, and where your marks would be given for a question like this. Okay, so there are a few fundamental things which just make our life a bit easier. Let's just draw in our axes. Now remember, you'll be given an answer sheet, so that will be given to you. I'm just going to make my axes a little bit bigger so that it's a clearer graph for you all to see. Okay. If we have any perfectionists on this call, I'm sorry for the lines that you're all currently seeing. Remember, when we do an inverse, everything is the opposite. Okay, so in this exponential, our asymptote is y is equal to 0. That's our current asymptote, which means our asymptote in our inverse is going to be x is equal to 0. We do actually need to state that in the asymptote. We always need to label our asymptotes, and we get a mark for labeling our asymptotes. So you don't have to try and draw the dotted line over the axis because no one will see it, but you do need to write x is equal to 0 where that asymptote is. Okay, then the next thing which makes it easy is, remember I said that the points when we do an inverse just change around from each other. So this one was 0 and 1, which means it's going to become 1 and 0 because they flip around. And this point here was 4 and 16, and so it's going to become 16 and 4. Okay, and we know that x equals 0 is our asymptote. I'm just going to make this up there. Okay, cool. And so we know that our line can't touch our asymptote, which means it's going to go away from our asymptote, and then we need to get into that point over there. So it should look something like that. Whose graphs look similar to mine? Let me know. Did yours look sort of similar, or does it look horribly different? Hopefully a bit neater than mine. Are we happy with our graphs? Are they good? Are they bad? Did you label it? Oh, horribly different. Okay. Yeah, that's okay. Do you see, though, what made this easy? Like what things we could do to make it easier in the future? Jaden's got a thumbs up. Cool. Okay. So let's just kind of write some little notes to ourselves when we're doing these things. First thing is look at your original asymptote. So our original asymptote was y is equal to 0, and so it's going to become x is equal to 0. And then second thing, look at your points. And so we had 0 and 1, and it's going to become 1 and 0. We had 4 and 16, and so it's going to become 16 and 4. Okay, and once we've got those points in, we should get marks. Now, the cool thing with these types of questions, but the table makes your life so difficult. I mean, you can always use the table. It's just like when you're in your matric exam, you're going to feel stressed with time. And so if there's anything we can do that can save time, we want to do that. And switching the points is like a nice, easy way for us to save time. Absolutely. It's 100% safe to say that every single time. As soon as it's an inverse graph, you can just interchange X and Y every time. That's what makes inverses cool. So your marks here is you would get a mark for showing your asymptotes. It's out of 4 marks. You'd get a mark for having the correct shape of the graph, and then you would probably get a mark for each one of those points that you've labeled, because it's out of 4. Okay, cool. I feel like that was a useful question. I'm really happy. Okay. Oh, does anyone need to sit here any longer? You can put your hand up if you don't want to say anything, just to. Okay, cool. Okay, November 2018. Sure, when this paper came out, people were not happy. Let's have a look at this. In the diagram below, the graph of f of x, which is ax squared, is drawn. Okay, so let's just figure out what's going on over here. These were all the papers that you guys would have written. The national paper, the November ones. So you all write the same one from Gauteng, KwaZulu-Natal, Cape Town. It's all the same national paper. So these are sort of the standards of the questions that you should expect. Yeah. Is that a question that your hands up, or? Oh no, your mic was typo. Got it. Cool. Okay. All right. So this is f of x. Now we should be looking at this and be like, hey, f of x, which is equal to ax squared, is a parabola, and that is definitely not a parabola. What is missing to make this a parabola? Why does it not look like a parabola should look? What's going on with it? What's wrong with it? Think about what we spoke about right at the beginning of the lesson. Good. It's restricted. Yes, it's a restricted parabola, because normally our parabola would have another arm that comes down like this, but it doesn't have this arm. This arm has been taken away because it was restricted. Beautiful. Okay. And this was its restriction here. Its restriction was that x had to be less than or equal to 0. And so people saw this and they were like, what the hell is going on? And some of them didn't even know what graph they were dealing with, because it just didn't look like anything they'd seen before. But all it is a restricted parabola. Okay, so let's have a look at the next part. The graph of f to the negative 1. Now that's, as soon as we see that negative 1, that's telling us that it is an inverse, okay, is also drawn. And so this graph over here, this dark blue, is that inverse of f to the negative 1. Okay, they've told us that the point negative 6 and negative 12 lies on f. And they've told us that we have a point R, which is on our inverse. Okay, so let's talk. Is f to the negative 1 a function? Motivate your answer. So I'm going to ask you right now, that dark blue line that I've drawn there, because that's my inverse, is it a function? Yes or no? Good. Why is it a function? Because we have to motivate our answer. So right now we're sitting on 1 mark because we've said yes, it's a function. Now we have to say why, because there's 1. Good. Okay, excellent. So this is like our ruler test. If I chucked my ruler somewhere, I'm only going to get 1 point that my ruler hits on that dark blue line. Okay, so we would say, yes, it is a function. And we would say there's only one y value for every x value. Beautiful. Okay. If R is the reflection of P, so this is R and this is P. If R is the reflection of P in the line y equals x. Now, when we see this sentence, when we see reflection in the line y equals x, what does our brain want to think? What is that telling me? As soon as we see y equals x, we need to think of one word. Inverse. There we go. As soon as we see reflection over the line y equals x, we're going to think of the word inverse. And as soon as we think of the word inverse, we know we can just interchange our x and our y values. Okay, so these are like the little tricks that we need to pick up so that when we read questions, we know what we're looking for. So we can see that the values of P at the moment are -6 and -12, which means our values for R are just going to be switched around, -12 and -6. Okay, so these are like small little things, but they help us in the long run. 4.3, calculate the value of A. So A was part of this original light blue arm over here. And I would like you all to please try and find value of A for me. This question is out of 2 marks. Let's see who can get all 2 marks. So once you've got your value of A, chuck it into the comments for me. Or let me know. Chat to me. Talk to me what it is. No answers for A yet. Are you overcomplicating this for yourselves? Think about which equation it's going into, and then think about what coordinates you've been given for that line. Yes, Caitlin. Cora was so close, but this is a good learning time. So let's talk about those answers that have just popped up into the chats, okay? So we have y is equal to ax squared, okay? I'm going to sub in -6 and -12. So -12 is equal to a times -6 squared, which means I'm going to have -12 is equal to 36a. And so a is going to be -12 over 36, which means a is going to be -1 over 3. Now, the reason I'm saying this is a good learning opportunity is because, you see, if we were to draw that other arm, we can see very clearly we have a sad parabola. And if we have a sad parabola, then a has to be less than 0. And so if you had gotten an answer where a is equal to 1/3, which is positive, you know that something's gone wrong somewhere because we know it needs to be negative. And so a would definitely be -1/3. Okay, cool. 4.4, last one of this question. So at the moment, we know that the equation of f of x is equal to -1 over 3 x squared. I would now like the equation of the inverse of that function. Okay, and it's out of 3 marks because there's a couple of places where they're expecting you to fall into their trap. So try really hard not to fall into the trap in those 3 places. And let's see if anyone manages to get all 3 marks, all 3 out of 3. My hint to you to avoid traps in this situation is to think about the restriction. And at the moment, that's the restriction. Okay, can I go? Does anyone need more time? Ooh, okay. So I'm glad that you did that, because it's a super, super common mistake. You fell for one of the traps. Log is only used when we're dealing with exponentials. So the thing is, in our brain, we connect inverses to log and to log. We think as soon as there's an inverse, log must be involved. But log is only involved if it's an exponential graph. If it's not an exponential graph, log is not going to be part of its game. We are going to do an inverse of it still, though. So the first thing we're wanting to do, okay, so we're getting a root. Okay. The first thing we want to do as soon as we have an inverse is we want to switch around our x and our y. Okay, so we've got x is equal to -1/3 y squared. That's our first step. Okay, and I want you to just keep that in mind over there as we work through this. Now, I would say, well, that means that that's x divided by -1/3. And I'm writing like that so that you can see what our next step looks like. Whenever we have a fraction and we have divide by, we change it to a times and we flip it over, right? So that's actually saying x times -3/1, when we don't need that 1. Just writing all of these steps so that it makes sense, okay? So x times -3/1 actually just gives us -3x is equal to y squared. Now, if at this point you had written it like this, totally fine, okay? You do not need to have written it like I have on my left. If you've got it like I have on my right, that's beautiful. Now we need to square root it, okay? So when we square root it, normally when you see a situation like that, you'd think, oh, there's a problem, because I'm not allowed to have a negative under a square root sign because it would be a non-real number. But they've told us that x has to be negative, and a negative times a negative would be a positive. So actually that situation is fine. But so if you got to this point, give yourselves a pat on the back. You've got 2 marks out of 3 right now. If you've put a plus and minus, you are wrong. And it's because it's not plus or minus. There was a restriction that said x had to be less than 0. And remember, in an inverse, that restriction changes, which tells us y now has to be less than or equal to 0 in my inverse. And this is now my y value. And we're telling ourselves that that y value has to be negative, which means I have to have a negative sign outside my square root. So not plus minus, just minus. And that sneaky little minus sign is your 3rd mark. It's super sneaky. Did anyone manage to get all 3 out of 3 here? Did we sit on sort of, if you got to like this point over here, let's sort of put marks in so you can get an idea of where people would be. If you did the switch around, so if you got to this point, that would probably be 1 mark. If you got to this point over here, that would be 2 marks. And if you had the negative sign, that's your 3rd mark. You got to -3. Okay. Okay. So what sort of mark are we sitting on here? I think looking at your answers, most of you were sitting on about 2 out of 3. Did anyone manage to see the sneaky negative sign to get 3 out of 3? Look at you. Ooh. You should feel very proud of yourself. Well done. Because it's a sneaky mark. I know your whole high school experience, your math teachers tell you we're not trying to trick you, but it's all a lie. The whole point of this matric exam is to try and trick you. And the points of these workshops that you have with Watobe are to make sure you do not fall for those tricks, because you're smarter than them. Okay, let's go on to our next question. So this is all still part of that same paper. So this is still part of, I think it was November 2018. Yeah, November 2018. Okay, so now this was question 5 in that same paper. Okay, I feel confident that you actually will be able to do all 3 of these questions quite happily. But if you're feeling stressed, you're welcome to put in your answers as you move along, and I'll tell you whether you're on the right track or not on the right track. But I'd love it if you could give these first 3 questions a try for me. Does someone have an answer for 5.1 for me? The domain of F. Remember, domain is looking at all possible X values. When we find the X-intercept. Okay. Benedict, it's a good question. So let's talk through a few things here. If we're looking at the domain, right, we're saying what are our possible X values? So what is X allowed to be in this graph? Now, if we're looking at this graph, the first thing we kind of need to establish is what type of graph are we dealing with? And we are dealing with a hyperbola. Okay, we don't have any, yeah, good. We don't have any shift moving up, but we do have this X is equal to 1 asymptote. Okay, so what you've written there is beautiful. X can be any real number, but X is not allowed to equal 1. So basically that's the asymptote. Okay, so if we're looking for our X-intercept over here, like this, the reason you're going to run into issues, so I'm just going to do like a little basic sketch there, Benedict, to try and answer your question, is because we haven't got a vertical shift. If you have a look, my graph actually doesn't pass my x-axis at all. It doesn't go through it. And because it doesn't go through it, I don't have an x-intercept. And that's why it's always going to cause an issue for me. So sometimes what's helpful is to kind of just sketch out the graph in a very basic, easy way to see what's looking, because then we can see, okay, well, we definitely have a y-intercept, but we don't have an x-intercept. And then you know what you need to look for and what you don't need to look for. And so then you don't waste time looking for things that aren't there. or getting errors on your calculator, which will just sort of leave you flustered. Do we have answers for 5.2? What are my two asymptotes of f? Yeah, so whenever I have a question on a graph where it hasn't been drawn for me, I personally find it easier to just do a very quick, easy sketch somewhere. And if you're worried that the marker is going to think it's an answer, you literally can label it working out if you're worried. Or once you've finished working with it, you can just cross it out like that, because as soon as it's crossed out, then it won't get marked. And then you would do the proper drawing when you have to draw it later. Okay, so let's have a look at some of these intercepts coming in. Beautiful, guys. This is also a place where lots of people fall into the trap of not giving the second asymptote. But our first asymptote is x is equal to 1, and our second asymptote is y is equal to 0. 2 marks. 1, 2. And for 5.1, if you don't have the whole thing, you wouldn't get that 1 mark. You could also have written it like this, for those of you who use interval notation at school. Okay. All right, so let's try and sketch this graph. It's out of 3 marks, and this is when someone asked earlier, I think it was Christian, asked how many marks it would be for drawing a graph. It depends on what's been scaffolded for us already. So because oh, hello, yes.
Hi.
Hi.
Just wanna ask, for the domain of f, you can't write x is smaller than 1.
No. So the reason we can't write that, thank you for asking that question, is because then you're not taking into account, if you're saying x has to be smaller than 1, you're only taking into account this arm of the parabola. You're not counting this one.
Oh, okay.
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 You could write it as x needs to be smaller than 1 or x needs to be greater than 1, as long as you write both of those.
Oh, okay. Okay, thank you.
No problem. Okay, so if we're drawing this, let's try and move that out a little bit. Because we did our little sketch, that makes our life a little bit easier. And because we've already had to answer asymptotes, that makes our life easier. So we've got asymptote number 1, which is y is equal to 0. We have to write that in. We've got asymptote number 2, which is x is equal to 1. We have to write that in. A is negative, which means it's going to be in this quadrant and this quadrant. Okay, and now we can see we don't have an x-intercept, but we do have a y-intercept, and we do need to find that intercept. So we're going to say, well, that's when x is equal to 0. So y is equal to negative 1 over 0 minus 1, which means y is equal to 1. So this point over here is going to be 0 and 1. Okay. And your marks for this type of thing, because you've already given the asymptotes, you would have a mark for that coordinate, a mark for your shape, so having it in the correct quadrants, and you'd probably get 1 mark for having both asymptotes written in and drawn. You do. I'm so glad you asked that question. When it comes to graphs, you know how you can spend all of this beautiful time showing all of your working outs. They don't even look at that working out when it's a drawing of a graph. The only place they look to mark is what you've drawn. And so if you don't put those points on your graph, you won't get the marks. And because they've said specifically here that they have to show all intercepts with the axes and asymptotes, if we don't write it in, we wouldn't get anything. Okay. Does anyone need to sit on this question any longer to write anything down or copy anything down? Okay. So this was all part of that same paper. This was one of the papers where it was worth a lot of marks. So let's kind of read through this blurb, and then I'm going to give you some time to work through this question. I'm going to give you, I want you to work through it fully. In the diagram below, A and B are the x-intercepts of the graph f of x, which is equal to x squared minus 2x minus 3. A and B. Okay. A straight line, G, so there's our straight line, goes through A and cuts F, and C is 4 and 5. Okay, so it's going through A and it cuts F at C, which is points 4 and 5, coordinates 4 and 5. And it hits the y-axis at 0 and 1. M is a point on F, so that's just saying that M lies on F. And N is a point on G, such that MN is parallel to the y-axis. MN cuts the x-axis at T. Okay, so the only new information that we're really gathering from here at the moment is that f of x is equal to x squared minus 2x minus 3. Otherwise, everything else for us has been drawn on this graph. Okay, I'm actually going to let you do all 3 of these questions. So these first 3 questions will be out of 8 marks. I want you to take it quite seriously. I'm going to give you more than enough time to do all of them properly. Let's see how we would do out of these 8 marks. Let's see if anyone can be brilliant and get all 8 out of 8. Or if we're sort of sitting somewhere in the middle, let's get an idea. So I'm going to give you some time to work on this question, and I just want you to do 6.1, 6.2, and 6.3. Yes, absolutely. Sorry, I missed that question. There we go. I was trying to get the questions to be a bit bigger for you guys, but hopefully you can see that all from So the reason that it's 3 marks is because I'm kind of giving you a little clue here, is you would have had to find the turning point. And so, yes, you would have to show some working out in order to get there. So this question is quite nice because it's bringing in a few of the things that we've spoken about today, which is good. Does anyone need more time to finish off still? Just let me know. You can just put your hand up as an emoji, or you can let me know if you need more time still. Okay, so we can start going through these. Okay, let's have a look. Oh, just a little bit. Oh, no problem. No, absolutely. There's no rush at all. We got lots of time. You guys are doing so well. I'm so proud of you all for being here on a Saturday morning. I know how tough this is. So well done. All right, let's start going through these questions. So first things first, I hope you didn't fall for this trap because we spoke about it earlier. Because it says show that, it means that we aren't allowed to know this at all. We're only allowed to check right at the end to see that we're right. But basically, what they're asking here is find the equation of G. That's what they're wanting to know. They're just giving it to us in case we can't figure it out, and then we won't be able to answer some of the later questions. Okay, so if we've used any of that information, they will straight out give you 0 out of 2. So my recommendation is cross that thing out. We don't want to see it right now. We're trying to find the equation of this straight line G. Now a straight line is y equals mx plus c. Okay, we already know that c is 1. That's been given to us. So we actually already know that that's y equals mx plus 1 because that point was given to us. And then to find m, you could either use your gradient method, so m, which is equal to the change of y over the change of x. You could do that using 0 and 1 and 4 and 5. Or you could just substitute this 4 and 5 into here, which is what I would find easier. So I over here would say 5 is equal to m times 4 plus 1, which means 4 is equal to 4m, and m is equal to 1. But if you use the gradient method, you would have gotten to that same point. So m would be equal to 5 minus 1 over 4 minus 0, which is 4 over 4, which is 1. Both of you would get you the same point. So therefore, y is equal to 1x plus 1. Then we can see what they said, and we got the same answer as them, so we know we're right. Okay, so let's stop right there. Who got 2 out of 2? Let me know. Put those in the chats for me. 2 out of 2 for showing that y is equal to 1x plus 1. Or let me know if you fell for the trap, the show that trap, so that we know not to fall for it again. Nice, Jaden. Well done. Good. Beautiful, guys. Nice, nice. Lots of 2s out of 2s. Good. Good. Okay. Excellent. Okay, so far we're happy with 6.1. Good. Now we're going to move on to 6.2. 6.2, we need to find the coordinates of A and B. Now the coordinates of A and B are our x-intercepts, and our x-intercepts are where y is equal to 0. So all we need to do is we need to make y equal to 0. And we've got a trinomial, so we're going to factorize that. I'll come to that question right now, Benedict. Let me just finish this one off. And so x would be equal to 3, or x would be equal to 1, which means the coordinates of A. Oh, no. What have I done wrong? -3. Oh, +1. Sorry. I just can't read my own writing. That's what I've done wrong. So A would be -1 and 0, and B would be 3 and 0. Okay, let me just read through this question, Benedict. Don't we already know it has a positive gradient of 1 because of the line? Okay, so we know it has a positive gradient because it goes from being a lower value to a higher value. So no, we know it's positive, but we don't know that the gradient is 1. The gradient could be like, if I had y equals 2x plus 1, that's still a positive gradient. So we don't know for a fact that the gradient is 1. We have to show through working that the gradient is 1. 6.2, lots of people leave their answers with x equals 3 and x equals -1. So I want to show you how the marks would work here. You're going to land up getting a mark for A and a mark for B, and then you would only get 1 mark for showing your working out over there. So if you haven't actually explicitly written what A is and what B is, you'll end up losing 2 marks for such a silly reason. But because they've asked for the coordinates of A and B, we have to be specific. Okay, so let's look at 6.2. What are our marks sitting at for 6.2? Are we sitting at 1 out of 3, 2 out of 3, or 3 out of 3? Let me know. 1 out of 3, 2 out of 3, 3 out of 3. Yes! Beautiful, beautiful, beautiful. So far, lots of you are sitting out of 5 out of 5, which is amazing right now. Beautiful. Woohoo! Okay. Last question, before we jump onto the next ones. Determine the range of f. So in order for us to determine the range of f, we have to know what that turning point is, because we need to know what the minimum value for f is going to be. And remember, to find our turning point, to find the x value of our turning point, we say minus b, so that's minus -2 over 2a. Okay, and that gives us a value of positive 2 over 2, which is 1. Then we substitute that y value into our equation, and we would get 1 minus 2, which is -1, minus 3, which is -4. So we know that that point over there is 1 and -4, which means our range is y has to be greater or equal to -4. Okay. Working out here, you would get a mark for having the -4. You would get a mark for having greater than or equal to, but only, not 2 marks there, only if it's in the right context, and then you would get 1 mark for showing you're working out somewhere over there. So where are we sitting for 6.3? 1, 2, or 3 out of 3? Nice. Good job. Cool. That's awesome. That means that some of you are sitting out of 8 out of 8 right now, which is cool. Don't be sad. It's okay. 1 out of 3, it's okay. It's progress, and now you know what to do in your exams. That's the whole point of learning, is to figure out what we don't know so that we know it later. Nice, guys. Okay, so that one was sitting at 3 marks over there. Cool. Okay, 6.4. I'm going to try and zoom out a little bit so that you can see the graph for 6.4. Okay, I'll just leave you with the one question so far. Otherwise, I think it'll be a little bit too small. All right. Determine the length of OT. So let me get rid of all of these colors going on over here. Determine the length of OT if T lies on the negative x-axis and they're telling you that MN, which is this line over here, MN is equal to 6. Okay. It's a big question, but it is 4 marks. So they're telling you that MN is equal to 6. And knowing that, basically they're asking, what are the coordinates of T so that I can find what the distance from O to T is? Let's see how this one goes. Is anyone feeling completely overwhelmed by this question and feeling like they have no idea where to start? Okay. It's a big question, guys. It's normal to feel like this. It's a really big, hard question. Okay. But the thing is, well, I wanted to give you a few moments to kind of sweat it out, because sometimes this happens in the exam and you get to a question and you're just like, what the hell is going on? And it's very, very stressful. But I'm going to show you a few things to hopefully make it a bit easier. So if a question like this pops up, you're like, okay, I have a few places I know where to start. Okay. Okay, cool. We've got an answer coming in. So let's have a look. Let's have a look at what's going on. I'm going to kind of move up to the graph so that we can see what's going on. We know, I'm going to get rid of a whole bunch of things to make this a bit easier for us to see. When they told us in the explanation in the beginning that MN was parallel to the y-axis, all it was saying to us was that this line is at 90 degrees over there, which means we can use basically the idea of distance, okay? And it's telling us that MN is equal to 6. And MN is the distance of this y value, okay? So the y value of M minus the y value of N. That is what that distance is, okay? Which means it's the y value of our parabola. So our y of the parabola minus the y of the straight line is equal to 6. That's what that sentence is telling you, okay? And we already know that the y of our parabola is x squared minus 2x minus 3, because that's the y of our parabola. The y of our straight line is something we've already worked out, which was x plus 1, and we know that that needs to equal 6. Okay, so now let's start working this out. X squared minus 2x minus 3 minus x minus 1 is equal to 6, which gives us x squared minus 3x minus 4. I'm going to move that 6 over, so minus 6 is equal to 0. So x squared minus 3x minus 10 is equal to 0. Okay, which gives us a parabola, well, a quadratic equation. And so x minus 5, x plus 2 is going to be 0, which means x is 5 or x is negative 2. Okay, so it's giving us two different things for x, which means that at another point on this graph, when x is 5, the distance between my parabola and my straight line is also going to be 6. Okay, that's what that's telling me. But we can see that this point over here is a negative. So we actually know that t is negative 2, which means the distance from O to T would be 2 units, because that's what we're looking for. So although it's 4 marks, the final answer of saying OT is equal to 2 is actually only 1 mark. And this whole situation here is with 3 of those 4 marks. Is there anything about what I've written there that anyone would like me to explain again, or is feeling confused by, or anything? Let me know. This is your time to speak up. Okay. Y is t equal to negative 2? Yeah. Okay. Okay. I'm actually just gonna go through this question again. I wonder if I have space on here. Not really. Let's try and figure it out. Okay. So whenever we're looking at the length of a line, so we're looking at the distance of a line, I'm just gonna draw a situation over here. Okay. So doesn't matter. It doesn't need to be accurate. So just trying to get an idea of what's going on over here. Okay. So we're just going to call this M, and we're going to call this N, and this point over here is T. Okay. And this point over here is O. Whenever they're talking about the length of a line that goes between different graphs, this is saying that our parabola is higher than our straight line, right? And so it's saying the distance between our parabola and our straight line is 6 units. That's what they've told us over here. And so let's just write out what that sentence actually means. So the difference between the parabola and the straight line is 6 units. That's what that sentence is meaning. It's like just writing it in a different way of writing it. Now, the equation of the parabola, we know, is x squared minus 2x minus 3. That's the equation of our parabola. Okay. The equation of our straight line was x plus 1. So, and difference means minus. So our parabola minus our straight line needs to equal 6 units. That's what that sentence is saying. So let's try and work that out. So we're going to have x squared minus 2x minus 3 minus x minus 1. I'm going to move that 6 over. Minus 6 equals 0. Okay, now we're just grouping like terms. X squared, negative 2 minus another x gives us negative 3x. Negative 3 minus 1 is negative 4, minus another negative 6 is negative 10, equals 0. Now we're trying to solve for x over here. And so we have a quadratic equation, which means we're going to have a trinomial. X minus 5, x plus 2 is equal to 0, which means x is equal to 5 or x is equal to negative 2. Okay, so what these answers are telling me is that when x is negative 2 or when x is 5, the distance between my parabola and my straight line will be 6. That's what that sentence is telling me. Okay. And so that's telling me that my x value is -2, which means that this point over here is -2. And so our coordinates for t are -2 and 0, which means OT is equal to 2 units. Does that make a bit more sense? Cool. Okay. But remember, these are tough questions. The important thing is that when you get a hard question like this, is don't leave it blank. Like, don't panic and be like, I have no idea where to start. Just try and do something. As soon as you see, like a hint to yourselves is as soon as you see that they've drawn a line in your, I'm just going to move this so that it's a little bit clearer. As soon as they've drawn a line in the graph and they've told you that it's parallel, like a line like this, you know that they're going to do this idea of one graph minus the other graph. That should be like a little hint to you to be like, okay, that's going to be one graph minus another. And they will ask me a question about it later. So then you know that it's coming. Okay. Okay. Last one. And this is just for 2 marks. Hence. So that means using what you've just done. As soon as you see this word hence, let's just get a different color going on here. Hence means using what you have already figured out. Okay, and that's why it'll be worth less marks. Hence, write down the coordinates of n. Okay, so n is over here. N is lying on our straight line. Now, don't overthink it. We're trying to find the coordinates of n, but we already know the x value of n. Okay, so at the moment, we already know that our x value of n is -2. We just don't know our y value. So all we're trying to do is figure out our y value of n. Okay, let's have a look. So all we're going to do is we're going to stick it into our equation. So y is equal to -2 plus 1, which is -1, which means n is -2 and -1. Well done to those of you who got it. Okay, so in this question, the toughest question was definitely 6.4. Unfortunately, 6.4.2 relied on having an answer for 6.4.1, and that's why it's so important to not leave blank spaces, because we need to have an idea. So if you had really messed up 6.4.1, but you at least got an answer for t, remember, use that answer for the next question, because you get marks. Next to your tick, there'll be like a little CA written next to it, and that means continued accuracy. So it means you made a mistake earlier on, but we're continuing with what you did. And basically, it's a way so that you do not get penalized twice for the same mistake. So continued accuracy is your friend. Just don't leave blank spaces. Remember that the markers are on your side when they're trying to mark things. Whew, okay. I can't believe how fast time has gone. All right. This is from the May-June paper. So basically people who do rewrites or are wanting to write maths. Sometimes it's different groups of people. Some people who've already finished high school, if they're wanting to write the matric exams again, they can write in May and June. So this is from that paper. It's also a national paper that everyone writes. So it's the same standard as your end of year papers. And let's have a look at this question. So the graph of f of x is log 4 over 3x, and it's been drawn below. Point B is a point on f, so that's point B, and its coordinates are 16 over 9 and p. So 4.1, for which value or values of x is this log graph less than or equal to 0? Who can give me an answer? Think about it, read it, look at the graph, see what you can figure out, and then let's see what answers we land up getting. Let me give you a couple of minutes. There's a quick way to do this, but I want to see what you all do. Let me know once you've gotten an answer. It's a surprisingly nasty question. Okay. When you get a question where there's a log graph, which has been drawn for you, dealing with log is difficult. It's a bit nasty. It's not the easiest thing to do. So my recommendation is right at the beginning, when you see this log equation, because remember that would be what you're looking at on here, just work out what its inverse would be. So what its exponential function would be. So we're just going to remanipulate it, and we would get y is equal to 4 over 3 to the power of x. Okay. Because we're reworking that. Basically, if I was trying to find the inverse of that, at the moment it's y. So I'd say x is equal to log 4 over 3x. Oh, sorry, y. And then I'm making y the subject of my formula. That's all I'm doing. Okay. You don't have to do this, but it does kind of make things a little bit easier as you're moving down. So my first little hint over here is whenever you have a log graph, just write out the exponential version of it to help you as the questions filter down. So when we get to a question like 4.1, we've got two different options on how we deal with this. Whenever it asks in an inequality question like this, it's saying, where are my y values less than or equal to 0? Okay, and it's over here. That's where my y values are less than or equal to 0, which means in order to answer this question, I need to figure out what that x value is. And that x value is when y is equal to 0. So I've got two options. Option 1, I can sub it in over here. So I can say, well, y is equal to 0, and I've got log 4 over 3x. But I'm trying to solve for x, which means I'm kind of go backwards in my log form. And basically, I'm going to say, well, that's the same as me saying 4 over 3 to the power of 0 is equal to x. So I'm just reworking that log, and anything to the power of 0 is 1, which means x would be equal to 1. Okay, so that point there would be 1. And so I would have to say, well, x has to be less than or equal to 1. That would be my first answer. Now, another way of looking at this, I hope I'm not confusing anyone by giving two suggestions here. But another way of looking at that is, remember that it would be the opposite of our inverse over here. So it's the same as saying where x would be, because this is saying where y is equal to 0. So in that inverse, it would be the same as where x is equal to 0. And if I made x equals to 0 again, I would see that my answer is 1, because 4 over 3 to the power of 0 is 1. Both are perfectly fine. We should get to the same answer. We'll get an answer of x is equal to 1. And because we need to see this yellow little path over here, it's where it's less than or equal to 1. Okay. Is anyone confused by anything I have written up on the board at the moment, or have any additional questions about what you're currently seeing, or any questions vaguely about exponentials and logs, anything that you needing clarification on? Nope. Okay. Okay, in that case, once we have got that answer, there are 2 more questions here to follow. I'm going to change that because I'm giving you an answer. So I would like you to try and work out 4.2, where you have to find the value of p, and 4.3. We're making progress with 4.2. Your silence is starting to worry me a little bit. Yes. Yes, yes, yes. Okay. Okay. Those of you who are putting these correct answers in the chat, the question does say without the use of a calculator. Did you use a calculator? Oh, good. Excellent. Okay. I'm gonna give you a little bit more time so you can finish off 4.3. Okay, let's have a look. So the nasty thing about 4.2 is that they told us we're not allowed to use a calculator, which means we couldn't just chuck it into our calculator. At the moment, we know our y value, which is p, okay, is when we have log 4 over 3, and our x value is 16 over 9. Okay, now we can actually just see that we would have to square that in order to get to our answer, but we can't just write that because we're not showing all of our steps of working. But if we rearrange that log, so basically if we go backwards, we'll see that our answer is 16 over 9, and that's equal to 4 over 3 to the power of y. And then we could see, well, that's the same as me saying 4 over 3 squared is equal to 4 over 3 to the power of y, which means that therefore y needs to be 2. It was a nasty question purely because it said without the use of a calculator. However, if you had shown this step over here, and this is why I'm saying don't leave blank spaces, if you had shown the substitution just for writing that, you would have gotten 1 mark. And then you would have gotten a mark for the rearranging, and then you would have gotten a mark for your answer. Okay. All right. 6.3. 6.3 had actually already helped you with, so I'd given it to you as the answer earlier, which was what we'd written up here. So the inverse equation is just y is equal to 4 over 3 to the power of x. 2 marks. 2 nice, easy marks for your pocket. Okay. 4.4, they would like the range of the inverse. And now for us, even though that this is counterintuitive, because normally for us, log is the inverse. For us, this is the inverse, which means they want the range of that. So I want you to think about that for a second, and then I'd like you to give me the range of that equation. Think about, like, remember, if we drew ourselves like a rough sketch, think about where your asymptote would be. .2. Yes, sure. So 4.2, they've given us an x value, and we're looking for a y value, and we know that it is on this graph. Oh goodness, sorry, just scrolling away. We know it's on the graph of y is equal to log 4 over 3x. We know it fits onto that graph. Okay, so we're substituting in our x value that we know, that's that 16 over 9, to find the y value, which was p. Oh, sorry, I'm saying y is equal to 2. P is equal to 2, which was y is equal to 2. Okay, so if you want to, from this beginning, you could call this y p, if that makes it easier, but it's up to you. Now, because they've told us without the use of a calculator, we're not allowed to actually just put this log 4 over 3, 16 over 9 into our calculator, which means we have to rearrange it. And so what's happened here is we've just gone backwards. We've rearranged that equation. We've made this the subject of our formula, the 16 over 9, which would have left us with the 4 over 3 to the power of y. And then all I was doing in this next step was finding the same base as each other so that I could compare the exponents to each other. That's what happened in 4.2. Okay, 4.4, if we're looking for the range, we should have already established that you're welcome. Our asymptote is sitting at y is equal to 0, and our a value is above, so it would be sitting above the asymptote, which means our range is just saying that y has to be greater than 0. Now, be careful with these questions. Because it's an asymptote involved, that is not allowed to be greater than or equal to because of the asymptote. Okay, so because it's 2 marks, you would have gotten 1 mark for just having greater than, and then 1 mark for the 0. Sure, you've done so well, guys. 2.5 hours, half an hour to go. Stretched out, you're in the last little Last little stretch of the lesson. Do you need a 5-minute break, or would you kind of just want to use the rest of the time? Tell me where you guys' heads are at. Okay, I'm taking that we should keep on going. Okay, no break, sure. Okay, all right, November 2017, again, a national end of year paper. So again, in line with the standard you should be expecting in a few weeks. Let's have a look at this question. So hopefully we'll have time to get through this whole paper. We've been given f of x, which is equal to negative ax squared plus bx plus 6. And the first question is the gradient of the tangent to the graph f at the point -1 and 7/2 is 3. Show that a is equal to 1/2 and b is equal to 2. So this is quite a nasty question. I'm going to give you a few moments to see if you can try and problem solve, and then I'm going to talk you through this one. But I want you to sort of first try and think of it as much as you can. Just know that it is a nasty question, but it is out of 5 marks, so we kind of want to be able to at least get some of those marks. Okay. Okay, so let's talk through this question. This is one of those questions where I was saying they like to include things like calculus into functions. This is one of the ways that they can do it. Okay, so it's important for us to know that when we see certain words here, we need to think about where we're going. Whenever we're looking at the gradient of the tangents, that's a key to us to think, okay, we're going to be diving into calculus. Okay. Now, calculus, when I find, so if I have my graph of f of x, which is equal to negative ax squared plus bx plus 6, if I find my first derivative of that, that's going to be equal to my gradient of that tangent at that point. Okay, so let's try and figure out that just that first step, what we would be doing. So we have f of x. If I'm wanting my first derivative of that graph, I would have negative 2ax plus b, because remember your constant falls away. Okay. So hopefully we are all happy at this point over here. All right. Now, they've told us that the gradient of that tangent is 3 when these things are true. Okay, so now we can say, well, we know that negative 2ax plus b is equal to 3 when x is equal to -1. Okay, so we can say, well, negative 2 times a times -1 plus b is equal to 3, which means 2a plus b is equal to 3. Now, before I move on, is anyone unhappy with anything that is written on this board right now? This is your time to ask. Okay. The next thing that we know is that when we're looking at the function of f of x, yes, we are definitely going to do a simultaneous equation. When we're looking at the function of f of x, this would be our x value and that would be our y value. Okay, so this is equation 1 that we're working out. The next thing that we would be working out is we'd be saying, well, if we substitute in f of -1, okay, so I'm going to say f of -1, which would be is going to be negative a times -1 squared plus b times -1 plus 6. Okay, so that's that first step over there. We know that that answer has to equal 7/2. So I'm going to write, well, that's going to be equal to 7/2. And we know that because of those coordinates over there. So if I sort of just solve this, -1 squared is 1. So I'm just going to keep this as 7/2. -1 times 1 is -a. And then we've got -b, and we've got plus 6. Now, I don't want to have to deal with this over 2 situations. I'm just going to multiply everything by 2. So 7 is equal to -2a minus 2b plus 12. And that's equal to 7. Okay. Now, because it's a simultaneous equation, I want to get something to look the same as each other. So if I have a look on this left-hand side, what we were working with, we can actually we can isolate that 2a is equal to 3 minus b. And in the dark green, we can move that 2a over. So 2a would be equal to -2b and then 12 minus 7, which is 5. Okay, so now we've isolated 2a in both. You don't have to do it that way. You could have done the way where you minus or plus the equations from each other. Both are completely fine. But now basically we're wanting to say that this is equal to that. So 3 minus b is equal to -2b plus 5. So I'm going to move my 2b, so -b plus 2b is equal to 5 minus 3, which means b is equal to 2. Okay, so we've shown that b is equal to 2. And then to show that a is equal to 1/2, we can just sub it into either one of these equations. So let me just use a different color so you can see the difference. I'm going to say 2a is equal to 3 minus 2 because b is 2. So 2a is equal to 1, which means a is equal to 1/2. A whole bunch of work, but it is worth 5 marks. So they all are valuable marks. The thing with these types of questions, because it's a show that question, remember that means we're not allowed to know that information. You actually don't get any mark for showing that b is 2 and a is 1/2 because they've already given that to you, which means all of the marks here are made up of this bulk of information. Now, the good thing with this type of question is that if you were completely lost, remember they've given you those values so that you can carry on with the question. But I want to be very clear here that as soon as you see, and that's why I've tried to make it as big as possible, as soon as you see somewhere in the question, gradient of the tangent, I want your brain to go calculus, and then I want your brain to go first derivative is equal to the gradient. Okay, because even if you fall apart after that point, you would have gotten those marks over there. And any marks are better than no marks. Okay. I know it was a big question. Now that we have shown that a is 1/2 and b is 2, we actually know that information. So now we know that f of x is equal to -1/2 x squared plus 2x plus 6. Okay, and so I'd like you to work out question 4.2 and question 4.3. Okay. Run out of space here. I'm just going to do the best I can. Okay, so this is for question 4.2. So for question 4.2, nice guys. Okay, for 4.2, I'm wanting the x-intercepts, and x-intercepts are when y is equal to 0. Okay, so 0 is equal to negative a half x squared plus 2x plus 6. Now, in order for me to get rid of that 2 in my denominator, I'm going to just multiply it out. So I'm going to multiply everything by 2. So I'm going to get negative x squared and then plus, actually, you know what, I'm going to multiply by negative 2 so that everything is how I want it to be. So I'm going to get x squared minus 4x minus 12. Okay, you may have taken a few more steps to get there, and that's absolutely fine. Then we're just going to solve it as a trinomial. So we're going to have x minus 6, x plus 2, and we will get x is equal to 6 or x is equal to negative 2. Okay, so our intercept coordinates are negative 2 and 0 and 6 and 0. Okay, cool. Calculate the coordinates of the turning point of F. Yes, if you're using the calculator that can solve trinomials, you absolutely can chuck it in to get your x-intercepts. Totally fine. You just need to show what your final answers are then. And you would need to show, if you are doing it that method, you need to show this first step where you substitute in 0, and then you would need to show your final answers. Okay. Okay, turning point of F. We've gone through this one a couple of times today. Trying to think which color will stick out against all of these other ones. Maybe an orange. Okay, so the x value of our turning point, the x value is negative b over 2a. Okay, so negative 2 over 2 times a negative a half. And you can chuck that straight into your calculator to get your x value. So we're going to have negative 2 over 2 times negative a half, which gives us 2. So our x value is 2. And then we need to figure out our y value, which would be negative a half times 2 squared plus 2 times 2 plus 6. And again, just chuck that into your calculator. So negative a half times 4 plus 4 plus 6, which gives us 8. And so our turning point is 2 and 8. Well done, Benedict. A beautiful answer in the comments section. Excellent. Okay, now that you have got all of that information for the last 4 marks, well, not last 4 marks, the next 4 marks, you are going to, I'm trying to think of what you will need in order to draw this. Just the last little bit so I can scroll up. I want you to sketch your graph, and that's 4 marks, and then see if you can answer question 4.5, which would be our last 3 marks. And if you need me to scroll up, just let me know, but I think you should be okay. So we want to sketch this, and then we want to answer 4.5. Yes. The thing is, when you're sketching a graph, the more information you put on, the better. So put on everything you can. You can never put on too much, but you can absolutely put on too little. My graph is going to be very, very small, but I'm just going to do my best over here. I tried to, so I wanted you guys to be able to see the questions, but I didn't really leave much space for me to do anything. So just imagine my graph is considerably bigger than this. Oh. Oh. Okay, I know my graph is tiny, but do your graphs look similar to mine? Let me know. Yes, no, horribly different, exactly the same. Yes, nice. Okay, marks for this type of graph, because it's out of 4 marks, you'll get a mark for having the correct turning point, you'd get a mark for having both intercepts in the correct place, and then you'd have a mark for having the correct shape. And so by shape, I mean, if you were to draw your parabola, lots of people do this, so it's always very funny for us. But if you were to draw your parabola like a triangle and not a curve, you wouldn't lose that mark, because that's not a parabola. It's actually something called an absolute value graph. It's a completely different graph. So definitely wouldn't get a mark if it looks like a triangle. Always have a nice curve. Okay, I'm going to give you some time to finish your 4.5, and then I've scrolled down here so you can also see 4.6. Similar is better than nothing like the same, so I'll take similar. So 4.5 is actually quite a sneak question. Lots of different ways you could go about doing it. I'm going to show you the way that there's a way that you can actually just straight away see what the answer is. But let's go with the way that you would actually have to calculate it. So we're trying to find out where y is equal to 6, right? So if we put that into our equation, we've got y is equal to a negative a half x squared plus 2x plus 6. Okay, so I'm just going to move that 6 over onto the other side. So we're going to have 0 is equal to negative a half x squared plus 2x. And then I'm going to multiply everything by negative 2 to get rid of that. So I'm going to get x squared equals, okay. And now we can take out our highest common factor, which means it's when x is equal to 0 and when x is equal to 4. So that's telling me that when x is 0 and when x is 4, my y value of my graph would be 6. That's what that answer is telling me. That's what I've just worked out. Now, they care about where our graph is greater than 6. And so it's when x is greater than 0, but when it is less than 4. Because as soon as it becomes more than 4, then my graph is going to drop below 6, and vice versa with 0. So between 0 and 4. Now, again, with a question like this, if you mess up this last little bit where you have to do the inequality, that's only the last mark. So as soon as you see something like this, just know whenever we've got like f of x or g of x or whatever, that's talking about the y value. So we know where is the y value greater than a number, and so we can figure that out by subbing in the y value. And that sort of ensures that we will at least get some marks in the total, even if we don't end up getting all of them. For 4.6, it's going to be difficult for me to show this properly. How would you write it in intervals? Okay. In interval notation, you would say that, let's think about how you would write this. X needs to be an element of between 0 and 4. With curly brackets. If we were sketching negative x minus 1, okay, we need to know that it has to go through negative 1. So we have to, obviously my graph is horrific here, guys, because my scale is all off, but it has to go through negative 1, and we would need to work out that negative 1 over here is where it would cross my x-intercept, and so we would have a line like this. Now, my line is much steeper than your line should look like, but the important thing is that you've got the coordinates of negative 1 on the x-axis and negative 1 on the y-axis, and that would give you your 2 marks for 4.6. Okay, does anyone need to sit on this page? I'm hoping in our last few minutes we can try and sneak in one little extra question. Okay, I'm going to move down. We're going to avoid this one for the moment just because the conversation is going to take us a long time, and those ones will happen, or I don't know. Do you want me to go through 4.7, or would you rather go on to the next question? It's up to you. We're happy to do it, but I'm also happy to move on to the next one. Okay. All right, let's have a look at 4.7. Yay. Okay, 4.7, these types of very clearly we want to do 4.7. That's cool. I'm happy to do 4.7. 4.7 is these types of inequality questions. They do pop up, and they also pop up in calculus, so don't be scared of them. I want you to think about it as sort of almost get your brain back into when you just learned about integers in grade 8. And when we learned about integers in grade 8, we knew that if we had a positive and we multiplied it by a positive, we got a positive answer. When we had a negative and we multiplied it by a negative, we got a positive answer. If we had a positive and we multiplied it by a negative, we got a negative. And if we had a negative multiplied by a positive, we got a negative. Okay, so this is like very rudimentary. It's like all the way back in grade 8. It's just thinking about when we multiply two things together, do we get a positive answer or do we get a negative answer? Okay, now, like I was saying to you just now, when things are written as f of x or g of x, that's talking about the y values, okay? And so this is saying the y values of f times the y values of g need to be less than 0, okay? Which means we are wanting a negative answer. And so we are looking at this section down here because they gave us 2 negative answers. And so that's saying that we care about where f is positive and g is negative, or where f is negative and g is positive. Okay, so I'm just going to quickly try and sketch a better version of those graphs over here so that I can highlight things. So let me just quickly get this graph down here. I'll be 2 seconds. Okay, so we've got -2, then we've got 2 and 8, and 6 and 0. So let's just draw this parabola. That's -2, that's 6, that's 2 and 8. Okay, and then we have our straight line. I'm going to draw it in green, which was -1 and -1. Okay, so now let's try and put together what we were talking about here in orange and sort of place it on this graph. First situation, where f is positive and g is negative. So f is our parabola. So our parabola is positive for all of this distance, right? That's where our parabola is positive. And our straight line is negative over there. So we're trying to see where is it that both of those things are true. So where is our parabola positive and our straight line negative at the same time? And this point over here up to there, they're both positive, so we don't care about that. But from when x is greater than -1, or it's allowed to also be equal to 0, then -1, then my parabola will be positive and my straight line will be negative until we get to 6. Because now at 6 we have a problem, because 6, it's going to be negative again, and then both of them are going to be negative, which we don't care about. Okay, so we're saying, well, x has to be greater or equal to -1, but it also has to be less than or equal to 6. And that would be our first situation. Now we have to look at our second situation. Second situation is where our parabola is negative, and our parabola is negative over here, and it's negative over here. Okay, and our straight line has to be positive, and our straight line is positive over there. So where is it that both of them, where both sort of cases are being solved? And we would have to look, well, that -2 is helping us. It doesn't help us at all over here because both are negative all the time. And so when x is less than or equal to -2, then my straight line will be positive and my parabola will be negative. And that is 4.7 in a nutshell. It is a tricky concept. Does anyone have any questions about 4.7, or is there anything that you're feeling a little bit lost about? They also love asking this question, but flipping this around. So saying, where is it going to be greater than 0? And then you're looking at this. So where are both of my graphs positive and both of my graphs negative? So you just need to think about what it's asking, and then think about, are they asking about where one's positive and one's negative, or are they asking about where both are positive and both are negative? I hope that that's made that clearer. Does anyone have any questions about 4.7, or feeling a little bit lost, or would like clarification? I think the most important thing to take from a question like this, I'm guys, I'm trying to soak up every last second that we have of these 3 hours. So I'm just going to draw something quickly. If we have a graph. The most important thing to take from this is that when it's asking when something is positive or negative, so let's just draw just like a normal parabola. Okay. It's positive when it is above the x-axis. So those greens are where it's positive, or bigger than 0 if you're looking at an inequality. And this part here, anything below the x-axis is where it's negative. Okay, so any type of question where they're asking you about an inequality, it's asking about where is it higher than the x-axis or lower than the x-axis. And so the things that come into play, the things that are most important in these questions are our x-intercepts. So for example, in this question, let's say that this was -4 and 4, and let's call this graph f of f. If I was asking in this situation, sorry, Coco, let me just 2 seconds. If I'm looking at f where it's negative, so where is f of x negative? I would be saying, well, x has to be greater than -4 or less than 4. And then where is it positive? It's when it is less than -4 and greater than 4.
I actually had a question, ma'am. That wasn't quite where I was going with that.
I thought that you were going to tell me to stop talking. Tell me your question. I'm ready.
Yes. Is it possible for us to solve this algebraically? Because I feel like if I have the equation for f of x and I multiply it with my equation for g of x and I make both of them greater than 0, I should technically get to the same answer. No?
You can. You definitely can. You absolutely can. The only thing that sometimes happens with that is you land up with a cubic, which can be difficult to work with.
Yeah, unless you absolutely know what you're doing and you know you have to use cubic functions, then it might get a little bit more complicated. But yeah, that was
absolutely, yeah. Benedict was saying they wanted to know that as well, and that's absolutely, you can 100% do it algebraically. Yeah. It just sometimes takes longer. So normally these questions, they'll put it right at the end of the question, and sometimes it's only worth 1 mark, sometimes it's worth 2 marks. In those moments, if you are only comfortable with doing it algebraically and it's only out of 1 mark, it's not necessarily worth the time that's going to take. Rather go on to the questions where you're definitely going to get all of those marks and come back to it at the end if you've got time.
Absolutely, yeah. And with that, I am going to actually ask for time because it is.
I know. I'm sorry.
Yes. Perfect. Thank you so much, Ms. G.
Sure. Let me stop sharing.
Okay, thanks, guys. This has been a really long 3 hours, but a very insightful one. Thank you so much. We've learned quite a lot. We don't really have homework for this, but we do have a lot of the exam question papers up on the app. So that's what we want you guys to go through. If you go through all the paper ones, just look for everything on functions and inverses and just try crushing all of them. I'm sure you guys will be okay. They're all on the app. You'll see if you click on topics, there's an exam revision topic on the Watobe app and on the website. So you guys will find those all in there. Okay, I'm just going to share my screen quickly. And
well done, guys. You did so well today. I know I just threw so much information at you for 3 hours and you just were amazing.
Yeah, that is, you guys, I don't know how you guys did it. I would have asked for a lunch break somewhere in between, for a snack break. All right, guys. So this is the only lesson we're actually going to have on inverses and functions and inverses. And you guys are absolute rock stars for doing this whole thing. And you guys, it shows that you guys have actually been practicing and getting on your work. Don't forget that this is the whole course schedule. If you're looking for it, it is available on watobe.co.za. So if you would like to see exactly what it is we'll be doing for the next 4 weeks, right up until your exams, we'll also be having a Q&A. So even the night before, bring all your questions, right? The night before your final exam, we will be here to help you guys. So if you guys can jot those down and have those ready for us for those last few days before we go into the final. And lastly, if you have any friends who you think will benefit from this, please tell them to join watobe.co.za. Ask them to come and join us so they can also benefit from all of this. And yeah, that's it from our side, guys. Thank you so much. Enjoy the rest of your Saturday, as will we. I think I'm going to go take a nap after that brain train. But yeah, thank you so much, guys, for joining us. Bye-bye. We'll see you.
Bye, everyone. Good luck for your exams.
Bye.
Bye.
Bye, Sparkins, Mindile.
Bye.
Bye, guys.